Hello everyone, welcome to V4. I am Kamal. So we are going to continue with number series. Today we are going to start with a new topic called reminders. So reminders is one of the important topic that we going to have questions. So I remember in one of my in CAT attempts in 2024, I had a questions based on reminders. I just solved the questions max to max 15 seconds. So I got 3 marks in that particular question. So reminder is so easy topic. You just need to know all the types of reminders and how to solve each and every types of reminders questions. That's it. So for now to know all this, what you have to know means you need to just make sure that you are learning all the types of reminders. For examples, Euler theorem, reverse Euler theorems, and then cancellation factor, Chinese remainder factors. So Chinese remainder theorems. You just need to know all these types of concepts and then how to solve each and every types of concept. You just need to know and solve few questions. So before jumping into reminders, my important thing is, as I said before, just try to pause the video, try to solve the question. After that you can watch the solution. Just try for like maximum 2 to 3 minutes. If you're not having any idea, if you're like completely zero idea means, then you can just start watching the video. Okay, let's first understand what is meant by reminders. So we already know what is my reminder, but still I will explain. Reminder is nothing but left out number after division. Generally, reminders are less than divisible. So that's what basically reminders means. So we already discussed reminders based on divisibility rules. But again, why we are discussing about reminders? Okay, there is a two important key differentiation you should know. What is the difference between divisible rules and reminders? In divisibility rules, okay, in divisibility rules, for example, we are going to have a number having multiple digits 1, 2, 3, 4, 5, 6. If I want to divide this number by 6, if I want to find my remainder, how we are doing this? This is what we discuss in divisible rules. But in reminders, what we are going to discuss means we are going to have a number. Okay, we are going to have a number with power. If I divide this number, what is my remainder? So in divisibility, we are going to have a number made by digits which are stacked linearly. Whereas in remainders, we are going to discuss how to find remainders if a number having its power. So that's a key differentiation. Now to solve this question, we are going to use two types of theorems. Two theorems. So when I say two theorems, don't bother about theorems because in aptitude it's all about of using applications of theorem. We are never going to study what is my theorem. We are just going to use the theorem's applications and results to find the answer. So here, what are the two important theorem we are going to discuss? One is Euler's remainder theorem, and second is Chinese remainder theorem. So there is not much of difference between them. I would say, guys, if you already watch my divisibility rules, then coprime numbers before watching this reminders video, I think you people can just like that able to understand what is meant by Euler's remainder theorem and then Chinese remainder theorem. So in this video, I'm going to just explain what is the key difference between these two remainders theorem and how we are going to solve the questions. If you know that, then solving the question will be easy, right? So when and where we used to use this remainder theorem means, then solving this entire type remainder will be easy. So there is a one more theorem called Wilson remainder theorem, which we are going to use for factorials to find the remainders by dividing any factorials. So as of now, we just discuss about these two. First, we are going to discuss about Euler remainder theorem. So Euler's remainder theorem. Basically, what is my Euler remainder theorem is, if I have a number, if I have a power, I divide this number by a divisor, I want to find my remainder. One important condition for Euler remainder theorem is the number, the numerator and divisor should be in co-prime to each other. For example, if highest common factor of n and d, if it is 1 means, then I can directly apply Rayleigh's theorem, Euler remainder theorem. So what is mean by that is, then how to find my remainder? There's nothing but, so you have to find the remainder by dividing the numerator by divisor, and you have to divide the power by Euler-Torsion number of divisor and find the remainder. Okay, so we already know if d is prime, then Euler number of d is nothing but d minus 1. If d is composite, it is nothing but d into 1 minus 1 by a into 1 minus 1 by b into 1 minus 1 by b. It keep on goes based on number of prime bases. These are the two different ways of finding the Euler-Torsion number. Okay, so I will explain with an example. Just listen here. I have, let us consider number 7. For number, it is raised to power 58 divided by 7. What is my remainder? So by seeing this question itself, I can say the highest common factor of 6 and 7 is 1. In that case, I just need to find 6 by 7, my remainder, and divide 58 by 7. What will be my remainder? 6 by 7, my remainder is 6 itself, because 6 is less than 7. 58 by 7. What is my remainder? The highest multiple of 7 which is less than 58 is 57. 7 eights are 57. So 58 minus 56. Difference is 2. So my remainder is 2. Eventually it will become 6 square, which is equal to 36. 36 is more than 7. So I am again dividing by 7. My remainder is 1, because highest multiple of 7 which is less than 36 is 35. So 36 minus 35, my remainder is 1. That's it. So basically, what is happening after applying Euler remainder theorem? This number is the numerator of this number is with bigger number having a 6 power 68 now is getting reduced to 6, yes or no? This power is reduced to 2 now. From this, what we can say is basically Euler remainder theorem help us to reduce the power to solve questions. That's the main agenda. So it's going to help us to reduce the power. That's it. Okay. I hope you understand how to apply reverse Euler as a Euler theorem. That is another concept called I'm keep on saying the reverse Euler. So which we are going to discuss while we are solving question. As of now, just learn this. I will go to next slide. So we are going to discuss about what is meant by Chinese remainder theorem. So what is Chinese theorem when we'll apply Chinese remainder theorem? We'll apply Chinese remainder theorem when my divisor is feels uncomfortable. Uncomfortable means I'm saying in terms of bigger composite number. My divisor is a too big composite number. Then what I'm going to do means I'm going to just split the divisor into product of two or more co-prime number. For example, if I have a number the power a device. I want to find my remainder. If my d is a bigger composite number, then I'm going to convert the d as product of two or more composite number like this, where here the highest common factor of a comma b just should be 1. Like this, after dividing like this, what I'm going to do means I'm going to find the remainder individually. Let us consider this remainder as r1 and find the remainder individually like this, r2, and then we are going to combine. So n is nothing but ax plus r1, n is nothing but by plus r2. Just combine this, it will become ax plus r1, which is equal to by plus r2. So we know how to solve this type of question, which we already discussed in reducible rules. If you know all these things, then solving this entire remainders is going to be matter of time. That's it. So just we're going to find the smallest common number. That's our remainder. So we are going to find smallest common number. That's just going to be our remainder. That's it. Entire remainder is going to be done if you know all these things. Okay. So that's what we are going to do. One is Euro theorem, another one is Chinese remainder theorem. So with this, we will stop the video. And next video onwards, we are going to start solving questions. I hope you enjoy this video. Thank you.